Hi everybody, welcome to the Greatest Data Show, SQL Beats 2020 Virtual Edition. My name is Tomasz Kastrun, and today's session will be about analyzing SQL databases with query store, extended events using R or Python. Couple of words about me. SQL Server database guy, data analyst, machine learning guy, data scientist with more than 15 plus years of experience in the field, frequent community speaker, and of course avid coffee drinker. If you want to get in touch with me, those are the links, please do so. Also, the code for this demo is also available for you if you want to dig in and dive in. First of all, let's make some context why this talk was born. We've all been in the situation that your SQL Server job is running late, or your query spilled to the disk, or sometimes my query is running, relatively fast, and then on the other day, maybe 5 minutes or so longer. So we all have had these questions in the past. And what were the usual answers? Well, let's wait and see for tomorrow if this happens. Or, we can add more RAM or more disk, or we can rebuild all the, indexes, stuff like that. So these were usual answers to your questions. But the frustration does not end here, because, let's wait and see what's going to happen tomorrow. Is this really the right answer? Or would really more RAM, suit your problem? And we are always at this phase and this time and this point that we are analyzing the situation with the tool. But what if, instead of analyzing, trying to be ahead of it, trying to be in a phase where we want to predict something? Instead of analyzing what has happened, let's imagine if it's possible that we can predict what's going to happen. Well, yeah. Okay. So the agenda for today is we'll dive into our Python and the cloud story. We'll get a quick overview about extended events, query store, and what we can get out of it. A couple of words about baseline and workloads. How to measure and what to measure, different approaches to searching for the patterns, and of course, my favorite, using statistics and using machine learning. To set the goals for today's session, we'll be looking into the SQL Server query store, how to measure using the baseline and loads, what are the alternative ways, and of course, as I said, approach of using machine learning instead of measuring what has happened. Let's try and set our goals to let's predict what's gonna happen. The persona for today is your usual DBA, to which I assume that all the DBAs are definitely looking into the machine learning, but that's the reason why I'll go into the next slide and just give you a brief overview of what's Python, presuming that you've heard of it, but you haven't really, used it. So just a quick introduction. R language used to be called S. It originates all the way back into the late 70s, but the first stable release was done in 1993. There's been a lot of stable releases. It's open source, functional imperative programming with support of the object-oriented programming. It's extremely powerful graphics capabilities with all the packages available. It is cross-platform and multi-paradigm. There has been more than 15,000 libraries or packages, all available on the original CRAN repository webpage. and it has quite a lot of people active in the community, especially in the data science community, since R as a language is used especially in particular for statistics and machine learning. And the community is definitely growing huge. For those SQL Server guys, R has been introduced in SQL Server 2016, continuing in 2017, and with the latest version of SQL Server 2019, R is also included. In 2017, SQL Server 2017, Python was also introduced. What is Python? Python is open source dynamic strong type scripting language, which also supports object-oriented programming. It's also extremely powerful with graphics capabilities, and it has a huge extension capabilities to do statistics and machine learning. The official website Python Package Index counts more than 200,000 packages. And a little bit of history. It originates all the way back to 1994. And there's been two branches, 2.x and 3.x. 2.x has been retired as of this year, January 1st. And 3.x has been introduced in 2008, and it's just had its latest release, which is 3.8. A couple of words about Azure. Also large and growing community. It's cross-platform, multi-paradigm. It also has this intelligent approach of scaling, of using the services, of using different type of languages, decoupling compute power, storage power, etc., etc. Why would we want to use Azure as a cloud service, especially for storing logs, telemetry in the blobs, using the computational power as a service, and of course for the leveraging the analysis using many different approaches, HD Insight, Databricks, automated machine learning, a couple of those which are extremely powerful. Virtualizing data, which is something new and has been introduced with SQL Server 2019, getting on board with Spark technology. And a funny note, a not good R marketing. This was taken back in the May 2019. As you can see, the most widely used and spread programming language, Java, and R has dropped significantly, whereas Python has gained its popularity over the past couple of years. If you want to follow the article, there is the link down below. R versus Python. R is out of top 20 programming languages despite the boom in statistical job is the title of the article. Go read it if you're R fan or Python fan, and especially if you're a DBA who wants to broaden the knowledge. Okay, couple of words about extended events. Extended events are lightweight performance monitoring system with literally little or no impact and load on the other resources and performances. Extended events fire synchronously and have limited impact on the system, can be processed and queried either synchronously or asynchronously, and in conjunction with event tracing for Windows, you can correlate quite a lot of stuff. Events are similar to SQL trace events, but are much more lightweight. There are more than 1,500 events as of SQL Server 2017, and of course growing. And you can write the query and you will see for yourself the amount of the events available. And Query Store. Query Store is a simulator, flight simulator, as it was introduced and named, to know what's happening with your SQL Server. You can get the full history of the execution plans. You can find the most expensive queries. You can find the regression of a particular query over time, and it's very good for forcing plans, especially when you are on vacation or during the night when you need to fix something relatively quick. You can force a particular plan and then in the morning get back to the work or after a couple of hours and then fix the problem. But the best way and the good part of the Query Store is also it's gathering statistics for any additional statistics analysis, which is the core focus of this session as well, because it's not only for forcing plans or finding regressed queries over time, but it also stores quite a lot of interesting information about understanding of a particular execution plan, and you can use these statistics to just literally play with, advanced statistics or machine learning or predictions or stuff like that. Okay, so we'll do a quick demo with R and Python using Query Store and using data selected with extended events. And basically, I will not go into how to set up the extended events. I will just have my data prepared because I already did that. So I'll just briefly explain what the data basically is about, and then we'll go and dive into a couple of statistics. Okay, so now I will switch to SQL Server. So SQL Server, I will use a couple of examples just to show you what Query Store can be used for. So this will be the plan and the Query Store usage of statistics, with which I will then feed the data into my prediction model. So first of all, I will create a table to store my prediction model, and this particular query, which basically returns a couple of rows. So beforehand, I was basically just running a couple of queries just to generate the statistics with my Query Store. And upon that, I will use a linear regression, and I will try to predict the average duration of a particular query. And for that, I will feed in execution time, average row count, average CPU time, average query max used memory, and that's it. And I will do that especially because I want to have my model stored in the table, which I can either query later on or improve in the future, something like that. So I will just run this all together, and I have one row inserted, which is my machine learning model. So let's just briefly look at the model. You can see it's a binary representation of a code that basically is serialized as part of the R code. And this part is something where DBAs should communicate with data scientists in order to have something like this prepared. In this case, this is really nothing extraordinary. It's just a example how to use collaboration between DBAs and data scientists. And you can predict any type or anything that you want to do as long as it makes sense and you have a great use of it. So in this case, saying if I will be running the same query again and again and again with a average row count and average CPU time, I can predict the average duration of my next run of the query. So the query is simple as this, and I will be predicting the average duration for the next run. So once I have my model stored already in a table, what I will do is I will basically try to predict the time for a particular time frame or time window, and this is basically today. And what I want to do is I want to get my model extracted, which means unserialized, from the table. And this is the table where I'm getting my model from. So again, since there's only one row, I can, with great confidence say top one, otherwise don't do that. And I want to store the results of this prediction into a table where I want to have my query ID, average duration, etc., etc. But at the end, I also want to have my predicted duration stored. So again, if I want to have it, in order for DBA to know the rough predicted execution time. And I'm taking my model, so this is our script, and I am saying get the model from this table, get the input data set. The input data set is, again, this is my input data set. So presumably that, let's say that we are getting new data in from the query store, and I just want to narrow, the very small fraction of that window time and input it into my model, and then say, okay, grab that model and do the prediction. So once I do that, I'm just going to run it all together. I have 2 rows in my result set, and I can now run the table. So one was run beforehand and the other one was run right now. So you can see that this would be the actual duration of a query ID 17, and this would be the predicted duration. So the last prediction duration is much better than the first one. So if the first one was actual duration 93 seconds and the second one was 92 seconds, the second predicted duration was much better. And you can see that these were all the information that were fed into the model. Of course, you can add those, and you can also find the most important. Maybe, sometimes the logical I/O does not, or the average the average CPU time does not gain or count that much when it comes to the accuracy of a particular duration. And you can also, tweak that. It's called feature selection, and you can use either feature selection or a couple of different other statistical machine learning methods to find the right. And you can also to find the right variables or the input statistics. And you can also do that dynamically. In this case, I would only assume and advise you to store the model, the prediction models beforehand and afterhand, so you can do the comparison of the different parameters and different input variables. So once you have that, then you can, it's up to you what you want and how do you want to use the particular information with your DBA. Okay, the second one would be extended events. But before I go into that, I just want to explain to you my data set. So I'm going to R, and okay, my R crashed. That's great. Going into R, and I'm just gonna show you my data set. Okay, so these are the extended event statistics which I've been gathering on a couple of particular runs. There are around 32 different extended events. For the sake of the brevity, I've just changed the names to from 1 to 32, and there has been around 433 runs of a particular query, and I've gathered all the different statistics. And with those, then I will try to do some additional machine learning or a multivariate statistics. So I can do, let's say, feature selection, I can do finding the outliers, I can do some heat map, I can do some factor analysis, etc., etc. So this is the code that you can use in R, but for the sake of the demo, I've exported everything into Power BI, and just to give you a much better idea of what I'm trying to explain. So these are all the features, and this is the correlation plot, sort of like a heat map. And the beautiful part about this is that you can easily see if there are any particular correlations between different extended events presented here as a feature between on all the runs. And you can immediately see where are higher or where are low correlations between those extended events. And this is basically something that can be gathered either from the query store or from the particular extended events, as long as you have the data persisted in the database with some timestamp and the query ID and also the query plane, so that you can then go back and try to reverse engineer what was going on. But going further on, let's say that 32, 44 in this case, extended events is way too much. And what I want to do is I want to find a particular extended event or a subset of those extended events and try to go even a step further, trying to figure out what was going on and where the problems were. So what I'm doing now is I am basically using some multivariate statistics and trying to reduce the complexity of those 44 or 43 extended events presented here as the features. And why is this good? Especially when you try to understand what was going on, and if there are any groups of similar extended events that on those particular runs basically represented the same value or were part of the same measurement. And once I have those, I can see that now the analysis have created 7 structural measurements for my all extended events, and with those I can go on and continue and play along. So basically reducing the complexity of all the statistics available. Of course, since there is, as I said at the beginning, 1500 n plus extended events, you have to have at least, some idea what they are, but as I said, you can just grab them and later on play with something like that. And once I have this, I can go on and continue using additional statistics or trying to figure out why a particular query was running on this particular case, etc., etc. So this is one of those ways how to use extended events, or how to represent them in Power BI, or how to use them with some multivariate advanced statistics. Okay, now I'm gonna go back to the slides and try continuing with more ideas. Okay, we've somehow managed to see what are the common DBA tasks, and usually they have like daily, weekly, monthly checklist. And what the DBA usually do is they compare the baseline with the workloads. But sometimes those performances, can degrade, and it is what it is, and you need to do, some off the record or additional analysis. And what they also do is use case or unit case testing, and they also need to do some performance analysis, SQL Server optimization. And these are all those things that there is a lot of tools available, but you can also go a step further and start using advanced statistics or machine learning. So how do they do it? There are a lot of third-party tools, PowerShell or .NET tools. You can use any type out-of-the-box tools like Activity Monitor, Performance Monitor, Profiler. You can, do some copy-pasting from the Stack Overflow. You can ask a friend. You can use any type of Transact SQL, System View, or any, those SQL queries that are available online. Or you can just go about and use R or Python, and which is something that, worth thinking about. So where is this exact point where DBA meets a statistician? So you have a workload and you have your baseline, and this is what statistician or data scientist would call collecting data. And then you have generating data, which is something that happens repetitive, and what a statistician or data scientist would say analyzing. And based on that, it would get a result that would either mean now we need to optimize something, or now we can start solving something. So as long as there is data generating and that the statistician knows what has been going on, regardless of, if it's a SQL or SQL Server, as long as there are data, the statistician, with the help of the DBA, can proceed and start working on statistics. So the baseline is something which is a performance under normal condition, and the workload is any type of load that can be compared to the base load or the baseline. Usually we do the workloads, we do troubleshooting on the workloads, and we usually have the baseline as a zero ground for troubleshooting. And what would be the relevant measurements for a DBA and data scientist or statistician is what the DBA needs to say. If it says, we need to, work on query-based collected data, or we need to work on SQL Server database collected data, or hardware-based collected data, it's DBA's task to do it. But you can also combine all those. It doesn't really mean that you don't need that you need to analyze them separately. A statistician or data scientist can combine all the data and use, as I said previously, some feature selection to see which particular information or statistics is in a particular query run or particular case more informative versus the other one. So those don't need to be silos and then analyzed separately. It can be combined together. Of course, you can also use common sense, which in this case is a common thing. Or you can ask yourself about the business processes. Sometimes the business processes also reveal the gist of the problem. You can imagine working in a huge enterprise environment, and if you start working and analyzing your workload, what's going on, as you can see on the left-hand side, there is quite of different stuff going on. Once you break it down, let's say your ERP system, your warehouse, your bakery, your website, you can see that there are particular patterns that basically are common sense in terms of the business processes. So if you go and you analyze your ERP system, you know that usually people start working coming to work at 7 o'clock or 8 o'clock in the morning, and all the way until 10, 11, there's going to be quite a huge load on that system. And then there's going to be 12 around, where people go to lunch, and then starting back again at 1, 2, 3, and then after 5 o'clock, those systems will start slowly going down. Whereas, let's say the bakery, there is quite a lot of nowadays computers in the bakery as well, and you can see the trend is completely opposite. That during the day there is little activity, but then starting from 6, 7, 8 in the evening and all the way to 2, 3, 4, you can see that there is quite a different pattern of behavior on the systems versus, let's say, ERP. And this is what I'm saying is the common sense that you can use when analyzing the workloads. And there's also additional loads like daily, monthly, yearly processes, especially when you combine those ERP systems. So imagine on the last graph, you can see monthly cycles, and then there is this finance controlling HR stuff that usually is going on in the last week of the month, salaries, billing and stuff like that. And once you start breaking down those using common sense, using the daily business processes, you can understand what does not need to be analyzed with some high sophisticated statistical methods. That those are really common sense, and be aware of that. So where is the real problem? The real problem is how fast you can determine what was going on, and how many DBAs do you really need for that? What caused that? Is it A or is it B, or are those two things connected? And is it due to the reads or the writes on the database, or is it something that just popped in? So there's a lot of ways how to do and how to deal with that. You can use what if analysis, or you can use clustering, you can use decision trees, especially if the DBA gets on board with the statistician or data scientist. And statistical will definitely give you some idea, and the DBA can then get and solve the problem much faster. But going even a step further, as I said at the beginning, the thing is that usual traditional way of DBAs working was always searching for the cause, doing what if analysis, trying to find out what has happened and what was the cause of something. And what statisticians and data scientists are doing are usually trying to do some type of predictions. So instead of understanding what has happened, the DBA should slowly alter in the way of starting to understand what is going to happen. And this can be achieved by predicting. So once you are analyzing the causes, you're analyzing the history. The moment you start predicting, you are trying to not only analyze, but trying to understand what will happen in the near future. And those trends basically have been now visible with SQL Server 2017 and especially with SQL Server 2019. Why? Because of the, let's say, data virtualization using the external tables and decoupling the compute pools, data pools. And also, if you look at the intelligent query processing feature family, you will see that there is a lot of intelligence, adaptive and stuff like that now available. And these are all the indicators that, we don't want to be stuck in the history. We want to start predicting and analyzing what's going to happen. So having the baseline and the workloads to understand out of ordinary what has happened is a crucial point to understand, how to use multivariate and machine learning statistics using those script languages. And you can also analyze with different visualization tools or self-service reports or Power BI, as I said. And this is the real way to go. You can visualize it with Grafana, with Power BI, with some particular R or Python visuals. You can add any type of additional statistics, and you can add also all these common measures that are available either from SQL Server, database, hardware. Basically, you can start thinking out of the box and much broader in a way that, in a sense that the traditional DBAs or the third-party tools, what are not basically giving you this. So I'm just going to go through a couple of examples how to change that concept. So this is your typical day-to-day job visualization, if a job has failed, if a job was successful. And this is one of those things that usually, especially when you are having, let's say 10, 20, 100 jobs on a particular SQL Server instance, it's hard to determine who's caused or what has happened at a particular time. One of those things is just try to envision and start transposing the data, or just say, okay, I don't want to look at it as it is. I want to have it as a Gantt diagram, or just to understand the concurrency of a particular job. And this is a simplest approach to much better understanding what has happened, for instance, when you start analyzing your history log. And once you do that, you can start, pushing toward understanding what's going to happen. Time series is something that usually is not that common with DBAs, but it should be. Why? Because all the statistics are basically just timestamps with query 1 statistics, query 2 statistics, query 3 statistics. And why is that important? Because we ought to know, or we need to understand, if a query 1 was also the cause of the degradation of query 2. And this is basically just time series data. Imagine gathering statistics for a particular query run, especially those that are either running on a high frequency rate or are running longer. And once you can transpose those data into some time series, then you can start working with concurrency of a 1, 2, 3, even more queries, and understanding those particular values of a particular query. So in this case, one arrow is basically one query. So you would have like 3 queries on this slide. And you can imagine that, let's say that query 1 was the cause that query 3 was executing 10 minutes longer than usually does. So as we can start storing the data in a time series format, and this will definitely give us much more understanding why, for instance, my query was slow? Was it because of, I lacked some resources, or was I waiting for some shared log to be released, or was there some, poor indexing? So this is, again, something that DBAs should switch mindset and start thinking about time series. And also the data insight. So this is something that I have a demo for. So I was basically playing and calculating statistics on a particular table and how many total disk space was used versus unused space. And I can basically do calculations and statistics on any type of statistics, either from query store, or I can run it and store it myself and later use to get some knowledge, additional knowledge, derived knowledge from all those statistics. And clustering the query statistics. So this is, everybody knows this query, of course, but you can store the results of this particular query, or you can, imagine time series. You can run this every couple of seconds or so and store the just couple of those metrics in SQL Server, and later on start understanding based on your query ID why or how, based on input parameters like total logical IO, total logical reads, writes, you can understand and group those queries that have similarities in some clusters, and later on do some additional analysis and try to understand why these queries were, somehow similar. Was it executed by the same person, or there was the same flaw in let's say SQL statement. It can be anything, or they were using data from the same table that had poor statistics on, or poor indexing. So imagine all those scenarios that something like this can bring you. You can also do some sort of DNA of your session with a query store statistics. So this is a heat map representation of, let's say, a lot of selects, in this case fairly simple selects, and you can imagine that, and then you get statistics from your query store, and you can group those similarities together and understand why a particular table or why a particular query was different from the other one. And the heat map on the right hand side basically represents the correlations among different statistics gathered from SQL query, from query store, and particular set of select statements. In addition, you can start monitoring the monitor system. So let's say that you want to have, all the data gathered from the different systems, and you say, okay, what about, if something really has happened. So imagine, you're monitoring 15 different systems, and one of those systems, and there are events on these systems that are occurring, either good or bad, and you have some false positives and false negatives. And each time there is a false positive, something has happened, and each time there is a false negative, something has happened. And you can evaluate those false positives and false negatives if they were really true or not. And why is this possible, and why is this useful, especially if you have to have some SLAs or some enterprise agreements that need to be met for a particular company or for a particular client or for a particular service. And this is very useful when you have all the data gathered, and then you can basically do analysis of a particular event, if it was really happening, and if it happened, was it really true when, for instance, a monitoring system triggered a notification system. And you can also do elasticity of the database growth. So you can imagine that you have a day of the week, and then your database is growing, and you don't really pay attention to it. But once you basically say, okay, now I'm gonna go and gather all the logs of my database growth over the last, let's say, half a year, and I'm just gonna break it down to the days of the week. And this is what this box plot is representing, are the days of the week of a particular database growth. And you can see that, for instance, Thursday was quite low on average, but it had quite a lot of outliers, which meant that there was something peculiar going on. And then Wednesday was quite a lot of work was going on, but not that much, for instance, as on, let's say, Saturday. So this again can give you some aspect in terms of predicting the database growth. And why is this important? Well, you don't want to run out of disk, or you can see that on Thursdays there is quite a lot of outliers and there's something going on, and you can be prepared for that, but only once you understand what's going on. If you don't know what's going on, it's hard to be prepared for something like that. And you can also do, let's say, predicting a ticketing system. This is quite, interesting case, and you can play with it. Every big company, every enterprise has a ticketing system where, within the company or with the clients or with the customers, you are basically serving or solving some issues. And you can put on a ticketing system a prediction how fast something's gonna be solved. And I've seen many enterprises doing this nowadays, but it was something unheard of years ago. And it's great because a customer then can see, okay, my ticket will be closed until that particular day. How to do it? Yeah, you can use random forest. But what's the DBA? Well, DBA needs to provide the data, understand the data, and give it to the data scientist. What are the other DBA use cases? You can start, performance monitoring. You can start analyzing error and audit logs. You can start finding outliers or unusual states on your server. You can use and do telemetry data, those that are usually, let's say, visualized on Grafana. Well, you can do parameters sniffing. Well, I don't know if you can do it. I've tried to predict it, but I failed miserably, so that I'm just putting it in. But and you can also, let's say, predict statistics. Still something which is quite hard, but you can give some sort of notifications, some early notifications to your DBAs that this table might have a stale statistics next week, which again is something that is very good. And you can start using machine learning to do, the elasticity as we know in the cloud. You can start using machine learning as a black box. Azure offers automated machine learning for, especially saving time, do analysis and faster checks. You can also use Databricks, and you can also use SQL Server machine learning with R and Python. So what would be the usual case? Imagine trying to analyze my query problem. So on the right-hand side, you can see the query problem. So asking myself, is my query slow today? So I will be predicting query execution time. So how I can do that? If I use, for instance, automated machine learning with Azure, I can just put on some data and I can say, okay, the machine will use the best algorithm for me, and it will say, okay, based on those parameters, I want to find the best model for my prediction. Once I have that, I can basically find the best model. Again, it might be a little bit black box, but this is where a statistician or data scientist should come to DBA and start working with him. Even though if it's a little bit black box, it can definitely give you the best result. So you can also do simulations like Monte Carlo simulation, linear algebra simulation to find the best vector, in this case, of predicting the query time. So imagine I have a couple of runs and a couple of different statistics, and machine itself will basically give me the best solution and the best model to predict what if my query 3 query will use that many CPU, what will happen, what will be the time, etc., etc. And you can also explain why this was happening. So imagine this is also out of the box in Azure Automated Machine Learning. You can try to understand why was my query slow today, and try to understand it was because number of reads and not because of the CPU. It was because of disk I/O and not last date of update of a particular index. And you will also get the accuracy of a model, which is again something very fruitful and very powerful for the DBA. I'm just gonna go to the last slide because I'm running out of time. So the demo would definitely cover up those who are interesting. I can share you, but the demo will definitely has, the trivial problems like heap tables, query execution, job execution, extended events, partial with performance counters, query store, disk usage, and prediction, and also using automated machine learning available in the Azure cloud. So the key takeaways for today's session is: don't be afraid to team up with data scientists and your statistician guys. Measure and collect once, calculate many times. Use Python and R for predictive analysis, and data are only numerous time series data sets of the events. Remember that it's not just table, it can also be time series. And also call for action. Those DBAs, your next task, go to your data scientist guys or statistician, team with them and find great ideas, share it with community. And this is, where the concept and the idea will go from here on. Thank you very much. Feel free to contact me anytime, and the code also available. Cheers.